So this is part 3 of the 9618 variant for 1 May June 2022 Python implementation for the last question, which is question number 3. So let's go ahead and look at the question right here. A program uses a circular queue to store strings. The queue is created as a 1D array called queue array with 10 string items. The following data is stored about the queue. So we have the head pointer with an initial value of 0, then you have the tail pointer also with an initial value of 0. Then you also have the number of items in the queue, which is also going to be initialized to 0. So our first task here is to declare the array, the head pointer, tail pointer, and the number of items. So we are to declare those 4 things right there. So let's go ahead and look at what we have here. So I have my declarations going on between lines 3 and line 6 there. So you see that for the array, I'm actually using a list because that's how you can go about it in Python. You make use of a list because it's more flexible than having to use the built-in array classes or array library. So we have a queue that's going to hold 10 items and we're just initializing it to now or empty strings as it were. Then for the head pointer there, we're initializing it to 0, then the tail pointer to 0, and number of items being equal to 0. So of course you'd go ahead and copy this code and paste it inside of the evidence document. Then part B says that the function in queue is written in pseudocode. So the function adds data to add, which is a variable rather of an argument that this function takes. So it's going to be given an argument that it is going to add to the queue. It returns false if the queue is full, and it returns true if the item is added. The function is incomplete, so there are 5 incomplete statements there. So we are supposed to fill in the blanks right here. So I'm not really going to go through the logic of how you can perform enqueue because the video will be rather long. I actually have a separate video, videos if I should say, in which I go about the different data structures and how you should know how to implement these operations like enqueue, dequeue. There's also pop and push for stacks. So you can always check those ones out if you have the time. But I'll just explain the logic going on here. So something that you actually see is you see that the queue, or basically all the parameters right here, they are being passed by references. You see that the queue array is being passed by reference, the head pointer is by reference, the tail pointer is by reference, as well as the number of items, is it? And the data, right? So what that means, we have actually 2 ways through which we can pass arguments to a function. We can pass by reference or we can pass by value. So if we are passing by reference, we are just passing the normal address of that particular variable to the function, and it's going to modify the variable in place that is in the same place in memory, is it? But when you pass by value, you're actually giving it a value that the function can make use of. Again, I think I talk about this in my pseudocode series where I explain passing by reference and passing by value. So with that in mind, let's come to my implementation here. You see that instead of having about five parameters or arguments I have inside of this argument list, or for my header on line 10, I only have 1. Why am I doing so? Is because all the other elements there, or all the other parameters, they are being passed by reference. So it's what I'm going to do is on line 11, you see that I'm now using the global keyword to refer to the memory location where queue array, head pointer, tail pointer, and number items are stored. So that's how I go about it for this one. Then of course we now need to finish or complete the missing statements as it were. So the first thing that we need to do is we need to check it to see if the number of items is equal to the length of the array. So if it is the length of the array, it means that we cannot enqueue anything to the queue, so we simply return false. Then of course I forgot to mention that you can see I'm using annotations here. It takes data to add as a string and is going to return a boolean, so that's what this means right here. So line 15 there, it's going to return a false if the number of items is equal to the length of the queue. Meaning to say that the number of items in the queue, if it is equal to the length of the array, then it means we don't have any space to enqueue anything, so we return false. Again, remember what I said earlier on about knowing how to enqueue in the first place. So you can always check out my other videos about different data structures and operations that you can perform on those same data structures, so that you can really have a firm grasp of how you can complete such a problem if you were ever to come across it. Yeah. So then here what we need to do is we are looking at the tail pointer, because remember when you enqueue something, you are going to add it to the queue. So you are going to take the data to add and we are going to put it at the end of the queue, or rather where the tail pointer is currently adding. Think of how people join a queue, let's say in a supermarket or at a bank. Is it? Then next thing that we need to do is we need to check if the tail pointer is greater than 9, which is or rather which is equal to 9. Actually this is what I did here. So if it is equal to 9, it means that we have to update the tail pointer to be equal to 0. Otherwise, we simply need to increment the tail pointer by 1. Right? So that's the logic that we have right here. So tail pointer is greater than or equal to 9. Then here we are checking to see if tail pointer is equal to 9. Then it simply means that the tail pointer is going to be equal to 0. This then goes back to how a circular queue works, as it were. Then here we need to update the number of items. Since we were able to add an item to the queue, we need to update the number of items by 1 right there on line 27 there. So yeah, that's how you go about it. And yeah, as it happens, you would have completed the implementation for the enqueue function. So you'd go ahead and copy the code and paste it inside of the evidence document, as it were. Then moving on to part C, we have a function called dequeue that returns false. Take note that false here is actually in double quotes, so false is actually a string. So this means that this dequeue function is going to return a string, as it were. So if the queue is empty, or it returns the next data item in the queue, and we know that the next data item is equal to string. So yeah, it goes without saying that the dequeue function is going to return a string. So you see that here on my function definition, I annotate that it's going to return a string. Then we are making reference to the global queue array, head pointer, and number items, variables that we declared earlier on. And when we enqueued something right here, you see that we are making use of the same variables right here. So it means that if we did enqueue something, then we can then perform dequeue by making use of the same variables or updated values, as it were. So to dequeue, you first have to check if, to see if the number of items is equal to 0, in which case we return false, because you cannot dequeue when the queue is already empty. So to dequeue is to remove something from the queue. So if the queue has nothing in it, you cannot dequeue anything. Then if we have something, then we are going to take the element that is currently at the head pointer, and we are going to store that inside of this data variable. Then having done that, we need to update our queue, as it were, because remember this is a circular queue. So it means that with the head pointer, if the head pointer is equal to 9, then the head pointer now is to point to 0, because you have removed an element that was at the front there. Otherwise, if it is not equal to 9, then it simply means we have to update or rather increment the head pointer by 1, as it were. Then we need to decrement the number of items, since we successfully removed or dequeued an item. So number of items is going to be decremented by 1. Then eventually we are going to return the data item that we removed from the queue, as it were. So that's how you can implement the dequeue function. And of course, you go ahead and copy the code and paste it inside of the evidence document. Part D says that we should amend the main program to take as input 11 string values from the user. Then we are going to use the enqueue function to add each element to the queue. And we're also going to output an appropriate message to state whether each addition was successful or not. Then we are going to call dequeue twice and output the return value each time. So we are to amend the main program to do these things. So let's go ahead and see what I have going on here. So here again, I'm making use of the global queue array, head pointer, tail pointer, number items that we declared earlier on. So what I'm doing here is I'm simply just resetting the queue just in case there's something you need, but of course you don't really need to have this logic here. You don't need to reset it, as it were. You just go ahead and take the input from the user, but I'm just resetting it all the same here. So we are going to make use of the for loop that's going to run 11 times. Remember how this loop works. It's going to start from 0 up to 10. It's not going to go up to 11, because it's always going to be up to but not including the term that you would have specified here. So from 0 to 10, that's actually 11 times. So we are going to use the input function to get the value for I plus 1. Why the reason why we're saying I plus 1 is because to the user, we just want them to know that this is the first element, which is 1. So when the user sees this on the screen, it's not going to be giving the user the index positions, but it's going to be giving the user like the natural way we count. So it's going to be 1, 2, 3, 4, 5. But behind the scenes, I is initially going to be 0 as it were. So having said that, then we enqueue this value, the user that is input, using the enqueue function line 68 there. That is requirement number 2 there, is it? So we are adding that element to the queue. So we remember enqueue is going to return a boolean true or false. So if true, we are going to say was successfully added to the queue. So whatever the user input, we are going to tell them that it was successfully added to the queue. Otherwise, we are going to output could not be added. The queue is full. Then we are going to call dequeue function twice and output the return value each time. So here we can simply make use of, here we are just printing all the, rather this is just a space in between. So we have a new line, then we print 50 equal signs. You actually see this when I run. It's much easier to show you than to explain what's going on, but really there's nothing fancy going on. These are just 2 blank lines and a line of, a string of equal signs as it were. So here, since we want to run dequeue twice, we can make use of a loop. Instead of having to have 4 separate lines, we can just actually accomplish the same thing by making use of a loop. So we are using a for loop to run to dequeue twice. So the first time around we dequeue, store in a result, then output the value for the result, then do the same thing again there. So yeah, that's how you can satisfy these requirements on D item 1. And of course, you can go ahead and copy the code and paste it inside of the evidence document. So D item 2 requires us to test our program with the input data A, B, C, D, E, all through the way to K. So, and then take a screenshot of the output. So let me just pull up the terminal here. Clear out the terminal. So make sure that we're in the right directory. I see question 3. Yeah, I'm seeing it there. So let me invoke the Python interpreter there. So Python question underscore, rather is question 3 underscore J22 underscore v41.py, then hit enter. So enter starting string. So if I just scroll up here, you see that we have A, so string is A. So it says that A was successfully added to the queue. B, C, D, E, F, G, H, I, J, and K. So this is the 50 equal signs that I was telling you earlier on about, and this is the new line that I was talking about earlier. It's just for visual presentation, really. Then we dequeue attempt 1, so we dequeue A, dequeue attempt 2, we dequeue B. So yeah, you go ahead and take a screenshot of your output and paste it inside of the evidence document, and that's just about it for this paper. I'll see you in the next one.